Hello, hello, hello! Finally, we're here. Thank you so much for the people that are already here. So, guys, let's warm up. We're just starting. We have a lot to talk about, but before I talk, I just want to know a little bit, where are you from? Who are you guys? What do you do? Like, are you a DJ? Why are you here? Are you a DJ, music producer? What do you do in your life that ended up here in this October 12th in this live to learn how to build your MIDI controllers? I'm really curious, would like to know where you're from and what kind of things you do, right? I know that we have some sort of a broad audience, but we all share this passion of music and music technology, music with other stuff. And I think that today we're gonna get this glued together with the music with the other stuff. How can we take what we love and get this to another level? For example, Alinata from DJ from Cyprus. So DJ, how can you get your set to the next level? You can build your MIDI controllers. You can build crazy interfaces. You can even add some sort of LED installation to interact with your music. For example, if you're a DJ, you can make your own set. Like I have those squares here with the LEDs, which I really love LEDs. So after I started with the Arduino, I started to add lights to my instruments, and you can do this kind of thing. Taha Alajami, maybe I pronounced that like similar, music producer from Dubai. So if you're a music producer, you can build the controllers dedicated for your plugins, for example, or a mixer for your DAW. You can create shortcuts to your music production, so you can make your workflow faster. So you don't need to spend that much time using the mouse. We are a post-rock alternative band from Cuiabá. We really like technology on stage. So yeah, man, that's how I started making live music and adding my controllers so I could express myself in a different way, explore new possibilities that before were not possible for me. So you can really build unique instruments that not only will make you stand out from the other bands, from the public, but also you can create tools that will help you to express yourself even more, right? Because music is all about expression. I mean, there's other aspects to it, but it's most about self-expression. And when you build your instruments, you also can express yourself in the tools you make. It's another type of thought that we are not used to, because we just are used to buy things ready and use the way they are. But today I'm gonna try to get you into this world where the tools now are a creative process. So not only the music is a creative process, but also the tools, and how the tools can change the way you make music when you make the tools. That's something really nice, and I really like about it. Who else? So Gonzalo from Argentina. Gonzalo, I'm here from Rio Grande do Sul, so we are neighbors. Danielle from the US, currently building a synth module. So if you're already into synths, MIDI controller is just the next step. Niterói, Rio de Janeiro, so more Brazil, music producer. I had expand your Tractorino, but now I want to expand it more. Nice, Elinata. So Tractorino is a controller I made for DJs. I think it got really popular. A lot of people have built it and expanded because it's open source. So really nice. I would like to see what you have done. So please, if you can just send me pictures or videos, I'll be super happy. Regards from Mexico, Aisha Ronit. So regards from Brazil, Recife, more Brazil. Sydney here from Brazil, São Paulo, and people from Brazil so glad you made it. The live is in English, but hopefully next month already I'm gonna do this live similar to this one, all in Portuguese too, for my Brazilian amigos. Okay, hi from East Coast, US, web developer, architect, love programming, love music, want to build things to afford more creativity, but stuck at fabrication. So if you also are an electronics or programming enthusiast and like music, like creating stuff, also this course here is is great because it's going to mix. I think it's some sort of perfect mix between music and the technology part. So it can be in the music part wanting to add some technology, or you can be in the technology part wanting to know how you can mix this with music. So Daxian used to see the videos, build one with 4 knobs, want to make something bigger but having trouble with multiplexers. We can talk a little bit about multiplexers. We're going to have a Q&A at the end, or feel free to ask in the middle. Floripa, Artur Boscato. I go to Floripa pretty often. I love Floripa. Alinata, please, I don't know, find my email. We're going to figure out. And Artur, we met you. We met, me and Artur, in a concert this weekend, or past weekend, in the line to a really nice show, Vitor Ramil. So nice to have you here, man. Bom te ver aqui. Okay, people. So we already passed 7 minutes. Thank you so much for being here. And so, so welcome to the how to build your MIDI controllers. So yeah, so let's start. It's a lot we're gonna cover today. Just let me have some water. The live will be available until next Tuesday. Then after Tuesday, I'll leave it off, and I'll only leave to my students in my Nerd Musician Pro course. So until there, feel free to watch the replays. If you want to download the video, whatever, do what you want. But if you can't follow everything today, some things I'm gonna try to do with you interactive, but I can't just wait too much time because we have a lot to cover. If you get stuck in one part, you can just watch the replay later, but only until next Tuesday. Okay? So how to build your MIDI controllers. So what will you learn today? There's a little bit more than this, but it's this 10 main points here. We're going to talk a little bit about how to sketch your idea, or what's the best way to put your ideas in a circuit diagram or a circuit design diagram. So when you assemble your circuit, you know exactly what to do. We're going to talk about how to choose the components. This is really can get really confusing if you're starting. So I'm going to talk a lot about components, the different types of components and how to use them, everything about Arduinos, which will be the brain of our MIDI controller. We're going to talk about buttons, potentiometers, also called knobs, breadboard, which is going to be the best friend of our prototype. A breadboard is used for you to not have to solder your components. It's just for you to try things out, so it's perfect to test and learn. We're gonna learn about Tinkercad, which is an Arduino simulator and also a circuit design software. And in this Arduino simulator, we'll be able to simulate yours in the browser with me. And how to assemble your circuit. Then we're gonna go to real life, where I'm going to do the circuit in real life here, buttons, Arduinos, everything. And then some other tips on how to build enclosures and printed circuit boards, and some tips on, after that, how can you expand your MIDI controller, because there are infinite possibilities of things you can do. And if you were here yesterday and the day before yesterday, we had 2 student showcases. with Gustavo Michalik, Javier Garcia, and Janice Wilson. They are my students, and they are so good. They are pros now, but they started knowing nothing, and they built completely different controllers to fulfill their needs. So it's really limitless what you can do, and there's so much I can teach you in 1 hour, 1 hour and a half. But what I'm giving you here today is the basis for you to keep studying with me, or to know how to do your own research to build your own stuff, okay? So this here today will save you months, literally months of research. So it will save you a lot of time, because for me it took me months to learn how to build my first, and here it's all I wanted to know when I started, okay? So materials. We are going to need either one Arduino Leonardo or one Arduino Pro Micro to do what I'm going to do today, okay? So why Leonardo or Pro Micro? Both are exactly the same exactly the same Arduino. This is the Pro Micro, and I don't have the Leonardo, but the Leonardo has the same chip as this one. The only difference is that the Leonardo looks like this. So what's the difference? We're going to talk about it, but this one is tiny, you can solder, and this one is bigger, but you can put jumpers, which is things like this, so you can make connections without having to solder. Okay, so the Leonardo is good for you to making prototypes in the breadboard, and the Pro Micro is better for you to final projects. But both will be programs, they work in the exactly same way, okay? Also, we're going to need a breadboard. So a breadboard is this thing here. The breadboard is this thing here, where we're going to connect our components to build our prototype. And we're going to need some tactile buttons, 3 or more. A tactile button is this thing here, which is just a regular button, but it's easy to snap in the breadboard. We're going to need also potentiometers. So we're going to need here the potentiometers and jumpers. Jumpers are those wires we can use to connect things. So those are jumpers, okay? So let's start from the basics, okay? Just let me see if you have like any doubt from now. So nice people from Bogota. Leonardo not great when combining MIDI via 0 plus. Well, that's we can take a look at that later. But anyways, we're going to start with the basics. I know that most of you already know about that. But what is a MIDI controller? Because we're building the MIDI controllers here. So this maybe it's a little confusing for some, but let's talk about it. A MIDI controller is an interface that uses the MIDI protocol. So it can be any type of interface. It can be a keyboard, a launchpad, a mixer that uses the MIDI protocol. And what is MIDI? MIDI stands for Musical Instrument Digital Interface. MIDI is only a language. MIDI is a protocol. So MIDI was created so different interfaces from different brands, so they can talk with each other with the same language. So if you say note C with velocity, whatever, so if, just a second here, I'm starting the live here on Instagram. So how is the audio good? Oh, there's a difference in the channel. I don't know if I can make anything about it right now. Just I'm starting here and on Instagram. So my voice is Sounding doubled. Is it yet? Can you tell me? Here, does anyone else hear too? Audio signals? Is it happening now? Still? Please let me know. Now is fine, so okay, better now. I don't know exactly what happened, but okay, thanks. If there's any other problem, please let me know. Okay, let's come back. Great. So I was talking about, and if you're here on Instagram, please go to YouTube. We are live there. So we were talking about MIDI and MIDI controllers, and that MIDI is just a language, so different interfaces can talk with each other, okay? So here you can see, like, for example, a Moog synth with a keyboard from a different brand. And before MIDI, they couldn't communicate with each other. You couldn't use a keyboard from Yamaha keyboard, for example, with a Moog synth. And so what is a MIDI controller? A MIDI controller is just one interface that uses the MIDI protocol. And MIDI nowadays is used by so many other things. Almost overlapping signals like a phase. Still have that. I don't really know what's going on. So sometimes it's better still two mics simultaneously. What could be going on here? I don't really know. That's a shame on me. Hello, Gustavo wants to take your classes, but I wonder how... I'm gonna keep going, and please keep telling me if this thing is still happening. Yeah, we can understand, but it's weird. It's weird. I don't know if that happened in the other day, but let's keep going. Maybe it will vanish, or maybe we're just going to have to have double me. One is enough, two is too much. Okay, so why should you build your MIDI controllers? There's plenty of reasons, but one reason is that you boost your workflow in the studio. So for example, I built this controller here just with 3 buttons because it was for a client and he wanted one button, rec, play, and stop. So you can build something that's really simple. Or if you want to build a controller for a plugin. For example, if you like the Moog app, like me, I built this synth here that looks really similar to the synth. So this way I know exactly where things are. I don't have a generic controller that will make me waste time because I don't know where things are, right? Second reason, building a MIDI controller is super cheap. So, for example, this Arduino here costs, like, I already paid like $2, $2.50. I don't know how much is now, but like between $4 and $5 you can buy one. So it's super cheap. Okay, so building a MIDI controller is super cheap. Like this controller here, probably I paid like $40 or $50. Right, so for $40, $50 you can get a controller made by you the way you want, so you can save money and also you can express yourself even more. Okay guys, just let me make do a test here. I'm using my condenser mic, but I'm going to change to another mic here. So I am using now my phone here, which is worst quality, but if it's better for you, if you're not having this feedback, please let me know. I'm gonna do like this for a couple minutes, and you let me know if you prefer how it was before or if you prefer how it is now, okay? So who this course is for? So if you're a music producer, audio engineer, if you're a DJ, VJ, multimedia artist, video photo editor, electronic musician, electronic hobbyist, any of this, you can benefit from this course. Yeah, so people said that the sound is better. Yeah, I don't know what happened, but using my mic that's here was not working, so I'm using this one here. So guys, even if you are a video editor, you can build a MIDI controller. I guess Adobe Premiere, DaVinci Resolve, all accepts MIDI. If you use Photoshop also, and Lightroom accepts MIDI. And of course, all the DAWs, Ableton Live, Pro Tools, Cubase, Tractor, Virtual DJ, Serato, anything. Okay, and VJs too. If you use Resolum Arena, Modulate, Mapper, anything for live visuals, live light, video, all music, you can use a MIDI controller. This will help you, okay? So, before we start with the content, I always like to show a little bit of what my students in my courses, what they have done, what they say, because this way you know what kind of things you can build, or actually you can build anything, but just to show you that you don't need to have any experience. Most of people start with zero experience in electronics or programming. You can see here, this controller is from Patrice. He's opened a company and now he's selling his controller. He is a DJ and he started to build one for him and now he sells his controllers. André Solis, which he did one even for his thesis in his design course. It's pretty amazing. He did he's a designer, so he got his main thing and mixed with his other passion, which is music, and did this amazing controller. Here we have a big ass mixer, and he even did the PCBs. Gustavo Michalik, which we had on Monday here, he built a controller for like a channel strip with EQ and compressor. Micon, he built like this whole thing. He built this giant mixer for his studio. And Camilo, he built an arcade controller, for you to see that it's not like only big things, super design. You can really build simple stuff too. So who am I? My name is Gustavo Silveira and I'm from Brazil. And I'm not going to bother you here telling my life story. I just wanted to tell you that my background is in music. I graduated in music composition in Brazil, and then I did a master's in music technology after I already started building my MIDI controllers in the USA at Georgia Southern University. I'm not going to tell you much more. I have more videos where I do this, but I want to show you at least some of the things I have built. So I'm going to show you here some MIDI controllers I have done. And press here to come back to scale. Now, it's everything mapped automatically for you because of the MIDI script. Now you can control volumes, send but it could be anything. Hello, so those are some of the things I have built. I really like, you saw that I like LEDs. This instrument here, oh sorry, you're not seeing. So this instrument here is the main instrument that I have done. I went to the finals of the Guthman New Musical Instrument Competition in Atlanta in 2018. And this was a lot of work, but it mixes different types of sensors, pressure sensors and encoders and soft potentiometers where you track the position of your hand. It's called XT Synth. I have videos on my channel if you want to take a look. Unfortunately, it broke. It fell on the floor and it broke. So I don't have it here to show you, but I'm gonna fix it. Okay, okay, let's come back here. So just to let you know that I came from music, so it's really something that anybody can learn. It might take a while depending on the complexity of your controller, but truly anyone can learn all the aspects of programming and electronics, because in the programming part I'm going to make it as easy as possible for you, where you don't need to learn how to program. In this today you're just going to need to adapt some numbers in order to build your controller. But of course, if you want to build more complex stuff like this, I also have separate courses where I teach how to program. So basically everything you need to build any type of MIDI controller you can think of. So okay, so let's start. How do you start, or how I start? Really, usually I just sketch my idea on paper and then I put my ideas in a circuit design software. So first step after you think of, and try to not be limited by your knowledge in electronics, first sketch what you really want and then see if you can make it. See if you can, at least how can you use the different parts of your controllers. It's easier to start with smaller controllers. So people sometimes get to me with ideas of giant controllers, and I always say start small, because if you start with a big controller, when things don't go well, it's really hard to find where the problem is. And trust me, you're gonna have problems. Everybody have. I always have when I build the controller for the first time. But now I am really experienced on finding what the problem is really fast, which is debug. I got really good in debugging. And just because I started small, I know the different pieces. So if you start small, like learn how to write a button, how to use a button, then learn how to use a potentiometer. Can you use like just a couple buttons and potentiometers? Okay, now can you use several buttons, several potentiometers? Understand? So try to start small and then increase your ideas, get crazy. And the way you start is designing your circuit. Start with a few components and put in a circuit design software like Fritzing or Tinkercad. Fritzing is the most popular, but now it's paid. It was free. You download and you install in your machine, and Tinkercad is free, it's web-based, so you can do everything in the browser, and it has a simulator, so you can simulate, you can test in the browser if your MIDI controller or any Arduino project will work. So this is a circuit or circuit design, schematics. So this is what we're going to build today in the breadboard. Also, then I'm going to show you, give you tips on how can you turn this into a final project, like a bigger MIDI controller like this. And this is the schematic for a bigger MIDI controller. And of course, it doesn't need to look like this, it doesn't need to be with tactile buttons, right? It can be with, for example, arcade buttons. So now let's start talking about buttons. Let's talk about how to choose your components. So basically, we have inputs and outputs. Okay, so inputs is any information you give to the Arduino in a physical form. So imagine that you want to take information from the physical world, the movement of your body, how much light there's in the environment, the temperature in the environment, the humidity in the soil, the distance of an object from the wall. All of these are inputs, okay? So you can use tons of different inputs in your Arduino. Not only buttons and potentiometers, you can use all sorts of things. And outputs are the things that are going out of the Arduino, the things that Arduino is controlling. But we're going to talk about it. So inputs, mainly, we have on-off switches, which are buttons and toggle switches. So for example, this is a button. This is a button too. And this is a button too. All of them have two terminals. This one looks like it has four, but it only has two. This is one leg and this is another leg. And we also can have knobs, for example, which are potentiometers, for example, like rotary potentiometers, like this. We can have slide potentiometers, like this. So this is a slide potentiometer. Actually, this is a motorized fader because there's a motor here, but let's not think about the motor right now. So this is the same thing, like this slide potentiometer is the same thing as this rotary potentiometer. They are used in the same way. So if you see potentiometer, all potentiometers you're going, I believe, going to use in the same way, which are different from rotary encoders, which we're not going to talk about today because they are really different in the way they work, but you can also use rotary encoders. So inputs, on-off switches, and potentiometers and encoders, for example. Also, you can use sensors, like distance sensors, light sensors, pressure sensors, humidity sensors, temperature sensors. All sorts of sensors you can find, you can use in your Arduino and use it in your MIDI controller. So this is where things can get like really crazy, really different. You can build art installations, interactive art installations, and the sky is the limit. And outputs are the things that the Arduino will control, so such as LEDs, addressable LEDs. So this is the normal LED, which only has one color. The way they work, it's different from addressable LEDs, which are like those LED strips that you can control each LED individually. So those LED strips that you can control them individually are called addressable or digital LED strips. And also motors. So again, now here is a motor. So for example, a motorized fader is both an input and an output because the motor can also move the shaft. So the way a motorized fader works is complex. I implement this in the code in my complete course. So if you want to use motorized faders, you can use it. And so, okay, questions about components or anything that we saw so far? Let me see the comments, and I'm glad that now the microphone is better. So yeah, the video will be available until Tuesday. I'm a data analyst. Can I use a MIDI controller for MS Microsoft Excel? Oh, I don't know. I'm sure you can you can use buttons and build a MIDI controller and actually output characters, letters, numbers instead of MIDI notes. So sometimes you want to output like a stream of letters, like a shortcut, command +1. You can program your Arduino to press a button and output that. So that can be used in any software that you can use your normal keyboard to control anything. So yeah, I guess yes. I hope you get a little in detail with code and explain. I'm going to do as more synthesized, like short as I can, but as in a way that you can use in your own and adapt to your needs. You can use Arduino over USB. Yeah, guys, so any questions, please type here until about components. But I'm gonna keep going because we have a lot to cover, and I'll be coming back once in a while for questions, okay? So, now choose the brain of your MIDI controller, or the brain, or choose the brain or the microcontroller of your MIDI controller. So now we're going to, it's when we're gonna start to get deeper. When we're gonna talk about this guy here, the brain of your MIDI controller, okay? So first, I'm saying brain, microcontroller, Arduino. So just to tell you what is what, the microcontroller, the brain itself, it's only this IC here, okay? The rest here is working with the microcontroller. So the Arduino is a board that contains a microcontroller, okay? So the Arduino transforms information from the physical world into the digital world. You can use in robotics, home automation, MIDI controllers, much more. And there are different Arduino models with different features. For example, these two are different, right? They can differ in speed, like how fast it is, number of inputs and outputs, because you're going to put things in the inputs and in the outputs. And different Arduinos have different numbers of inputs and outputs. Some of them have USB connector or not, Wi-Fi, Bluetooth. And here we have some different Arduino models. The Uno, which is this one, is the most common one. It's really good for you to prototype things because you can put jumpers in those holes, such as the Arduino Mega. The Mega and the Uno are pretty similar, but the Mega is bigger, have more inputs and outputs. And you have the Leonardo, and we're gonna talk why I'm using the Leonardo instead of the Uno later. Why only the Leonardo and the Pro Micro, also the Micro. So I have the bigger ones here and the tiny ones here, so you can solder and put in your final projects. They are smaller, so they're better for final projects. And we even have here the TNC-LC. The TNC is an Arduino compatible. You program just like an Arduino, but it was made by another company. And the TNC is way faster than the regular Arduinos. It's great for MIDI controllers. They're just a little bit pricier than the regular Arduinos. And you have even weirder Arduinos, more different, like the LilyPad. For example, the LilyPad is good for wearables. You can put in your shirt and put conductive thread. So you can create like a shirt or a pillow or a blanket with MIDI capabilities, okay? So, okay, now let me see if we have questions. I would like to install motorized audio faders into a mixing console. What is the difference in building a controller with motorized faders, with motorized controller faders versus motorized audio faders? I don't know if I get your question. What is a motorized controller and a motorized audio fader? So if let me think that like, okay, a controller is just a MIDI controller. So a motorized fader in a MIDI controller, it's going to control your DAW and it's going to receive MIDI from the DAW. So the MIDI from the DAW will control the fader, and an audio motorized fader, I'm not going to answer because I don't know if I understood exactly your question. I want to build a 13-note bass foot keyboard with 2 buttons for octave plus minus. I'm thinking of using the pedal board from an old Yamaha and Electra. What input can I use for the keys? I'm 13. Input, you mean like buttons? If you want real keys, like from a keyboard, you can buy the keys, but it's hard to make velocity work. You can also use a used keyboard and just get the keys from the used keyboard, or you can really use just like regular arcade buttons, but those don't have velocity. The Pro Micro is great for MIDI. You can power it by USB, and the size also is good. Eugene said he asked a question, but I don't know if I saw Eugene's question, so please say it again. I wish I didn't have to go, oh, me too, man. A fader with audio passing through its via MIDI data. So if it has audio, it's processing the audio in the fader, right? Because the fader can decrease the amount of audio that you have. I guess that an interface with audio will be just way more expensive. That's for sure, because you have all the audio part, and that's the whole new world. And it's way more complex and way more expensive than just MIDI. So an advantage of just using MIDI is definitely the price. Pedal boards usually have a wire for each pedal plus a ground. Okay guys, let's get into more here. We're going to talk about, we talked about components. We talked about buttons and potentiometers, sensors. So inputs and outputs, they also differ in digital and analog. And that's important because the Arduino has digital and analog inputs and digital and analog outputs. So each pin here, so each pin or each hole is one input or output. Some of them can be both input or output. If they will be input or output, you're gonna tell the Arduino in the code. So in the code, you're gonna say, oh, pin 2 is an input or pin 2 is an output. And among the inputs and among the outputs, some of them are digital and some of them are analog. And some of them can be analog or digital, okay? And some of them can be only digital. I know that's a lot of information. We're gonna learn what's digital and analog. Just know that the different pins can be different things depending on how you use it in the code. But we need to know what is the difference between digital and analog. So let's come back here. In the inputs, we have the digital inputs. We have every digital input, we are going to connect a component that's only on or off. On or off. 1 or 0. Pressed or not pressed. Such as buttons. Or toggle switches. Those toggle switches are the ones that are just on or off. So in the digital pins, think that you're going to put a component that can be represented by one digit, 1 or 0. In the analog inputs, you are going to put components that have a minimum and a maximum value, such as potentiometers, distance sensors, light sensors, etc. So for example, this is not only on-off, it has a minimum and a maximum. This thing here has a minimum and a maximum. So this type of component you're going to put in the analog inputs, such as the other sensors. So everything that has a range of values is connected in the analog inputs. And in the in the digital outputs, or let's come back. So in the outputs, we have the digital outputs, and most Arduinos only have digital outputs. So if you remember, a digital is something that has only 2 states. So if you have an LED, you're only going to have 2 states, LED off or on. However, there's a technique called pulse width modulation, or PWM. This is a technique that we use in synthesis too, in many things. But with this technique, we can simulate or emulate the difference in brightness of the LED. So basically it makes the LED blink on, off so fast in a certain way that our eyes are tricked to think that the brightness is changing, but actually it's blinking so fast that it seems that it's dimmer. But anyways, just know that the Arduinos usually only have digital outputs, but you can change the brightness of an LED using PWM. So if you hear about PWM, that's what is this for. So how the Arduino works. This guy here, how it works. The Arduino works with 5 volts, so it needs power. So you can connect, it can get power from the USB, for example. The Arduinos with USB are USB powered, but also it has a power supply input. So this Arduino can be powered by a power supply connecting here. This one here has USB, but doesn't have a power supply connector. However, it has pins that you can connect the 5 volts of a power supply and the ground, so you can power the Arduino through its pins too. So how it works? With the components we used, buttons or potentiometers, whatever component we use, this current will be manipulated and read in the inputs. So for example, with the button, when you press the button, you will allow the current to flow through the button, and when it's not pressed, this 5 volts will not flow through the button. So in the Arduino input, digital input, it will have or 5 volts or 0. So this can be used as an information to control something else. So the components will change how this voltage travels through the Arduino. And this change in voltage will be read in the Arduino inputs. This reading will be converted to numbers in the ADC, analog to digital converter. So what is an ADC? The real world, let's say, is analog. The real world has infinite numbers between anything. You don't know how what's the minimum distance between these two hands, like how much can you divide? You can say that like maybe you can divide until the atom, but you know that there's things that's smaller than the atom. So you have infinite numbers to represent a minimum and a maximum in real life. But in the digital world, we have to limit this range to a certain range, okay? And so we need to convert this analog signal, the real-life signal, into digital. So we have this analog to digital converter. An ADC has a resolution. So, for example, we are going to have 0 to 5 volts. Arduino works with 5 volts. And we will have to quantize or divide this 0 to 5 volts into X amount of numbers. And this X amount of numbers depends on the resolution of the ADC. So for example, the Arduino has an ADC of 10-bit. So you have 10 zeros and ones to represent this number. So 0 to 5 volts in the Arduino, with this 10-bit resolution, you have 0 to 1023 possible numbers. So that's the maximum range. So if you are reading a potentiometer, in the Arduino you will have 0 to 1023. So in the Arduino Ide, which is the integrated development environment, which is the place where you're going to write the code, with a C-based language, we can program the Arduino to use these numbers for whatever we want. So we're going to have a potentiometer from 0 to 1023. But then I want to control MIDI, and MIDI is only from 0 to 127. In the code we can convert one range to the other, and then we can use this number to send MIDI control change. Or this 05 volts, right? That in the digital pins will be low or high. We can say when it's high, send a MIDI note. When it's low, send a MIDI note off. So like a note on and a note off. So these numbers then can be used to whatever we want. And then we need to write this code to do what we want. And the most complicated part, I already have done for you. I did all the complicated part, so you can just change how many buttons you need, how many potentiometers you need, and then your code is ready. So we can send a message through the USB, like we can send MIDI through the USB, or manipulate the output with voltage to blink LEDs, move motors, etc. So in the inputs, you will read the voltage, and in the output, you will send voltage 5 volts or 0. So with PWM, for example, you can use this to change the brightness of an LED or move motors, etc. So for example, if there's a button pressed on pin 2, turn on the LED on pin 6. So this is the algorithm. So this is the set of instructions you want to tell the Arduino. And then in the code, with a C-based language, you're gonna write this, and the Arduino will turn the LED on pin 6 when you press the button on pin 2, if that's what you did and if you did it correctly. Another great thing about the Arduino, it's open source, which means that the code for the IDE or the schematics, the circuit is all open for you to make yours. You can get the circuit of the Arduino, and send to a Chinese company and get your own Arduino, and then you can modify it and you can even sell it. So that's why it's so cheap, because Chinese companies build them and sell it really cheap. The original Arduino is Italian, costs more, so I highly recommend you to have at least one original to support the company, but then buy the Chinese ones because they're way cheaper and they are the same quality. Don't think that the Chinese Arduinos are lesser quality. They are exactly the same. Some of them will be a different model with different components, and you have to pay attention on that. But if you have an Arduino that's exactly the original, it's the same thing. Another thing about the Arduino, the community is huge, and there's so many forums, places that you can ask people, they're gonna help you. So to summarize what we have seen until now, The Arduino transforms information from the physical world into the digital world. With coding in a C-based language, one can tell the Arduino what to do with its inputs and outputs. Inputs and outputs can be divided into digital and analog. Digital, we can put buttons and switches. In analog, we can put potentiometers and sensors. Outputs are mainly digital, but one can simulate an analog output with PWM. Remember that PWM, that can change the brightness of an LED. In the outs, one can connect LEDs and motors. Digital input pins will give a reading of 0 or 1. So remember that we have digital and analog. So in the digital inputs, we're going to have 0 or 1. And in the analog inputs, we'll give a range of 0 to 1023, which will represent that 0 to 5 volts. Okay, guys, so let me just take a look here in your questions. If you have anything, please send me. My aim is to build a MIDI controller where it send and receive MIDI data. 74HC595 IKE vlog asked about this is a bit shifter. So that's a component that I actually teach inside my courses. We don't have the time to talk about it today, but for example, when your Arduino doesn't have enough pins, let's say you need 50 LEDs or 100 LEDs, or you need 100 potentiometers, you don't have space, you don't have room to put here, right? So for that, you need to add something extra, which can be bit shifters or multiplexers. Bit shifters will help you to, which is the 74HC595, will help you to increase the amount of LEDs you can put in your Arduino. And for example, an analog multiplexer like the CD4067, usually is the something 4067, will help you to increase the number of analog inputs in your Arduino. So know that you're not limited on the amount of pins you have in your current Arduino. There is a way for you to increase the number of inputs and outputs of your Arduinos, okay, using bit shifters and multiplexers. Again, that's all inside the courses. Oh, I didn't know about PWM on LED, Stephen said. So yeah, we know, we see PWM in sound, right? PWM changes so if you have a square wave, it changes how long the square is on related to how long the square is off. In sound, that changes how we hear the quality, the timbre of the sound. But if you do the same thing on an LED, just on and off, but changing how long the on is compared to how long the off is, pulsing in the same speed, ta 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 ta, you change the brightness of the LED. So that's crazy. Oh, hey man, are you living in the US? No, I am in Brazil right now. I was there until 2019. Let me see. Anyone using Raspberry Pico? I'm yet to use it. Haven't used it yet. I think it's great. I don't know how about the libraries, because there's so many libraries for the Arduino, so it's just so easy to find things. So I don't know how it's to a Raspberry Pico, but I'm definitely gonna take a look at that. There's a way to integrate a Bluetooth module like the HC05 to your code. You can integrate anything to my code, no problem, but then you need to do it yourself. I have a ESP32 which has Bluetooth, which I used there in my LEDs. They are controlled by my cell phone, and I am using the ESP32. And you can use that for Bluetooth, and I'm gonna add this to the course too. Also, and send serial data and MIDI at the same time with the same Arduino. I want to control. You can send serial. You can send serial, for example, through a physical MIDI DIN, and MIDI through the USB. You can even send different things at the same time. I want to control the axis of the mouse with 2 potentiometers. Is that possible? Yes, you can. There's a library for the Arduino Pro Micro and the Leonardo that you can output letters, numbers, and also control the position of the mouse. There's a really nice controller in the market now that was in Kickstarter that does exactly that. So you can use potentiometers or rotary encoders and control the position of your mouse. So you can just put the mouse on top of your knob in the DAW and then use your controller for fine tuning. It's really great. Okay guys, so let's get going. So how many, okay, so which Arduino to choose here? How many components you want? So when thinking about the controller you want to build, how many components? For example, the Arduino has 12 digital and 6 analog. And by the way, to know how many pins they have, please just Google Arduino Uno pin out or Arduino Pro Micro pin out. You will see that some pins have more than one capability, but just Google that to know which pins do what. So the number of inputs is important when choosing an Arduino. MIDI class compliant, super important. MIDI class compliant means that you can plug the Arduino and it's going to be recognized as a MIDI controller, not an Arduino. Not all Arduinos do that, so that's why I choose this one, but we're going to talk about it. Is it for a prototype like this, or like this? Is this a prototype or it's a final project? So I'm going to talk which are my favorite Arduinos. That's going to save a lot of time of research. My favorites are the Arduino Uno and the Leonardo. I mean, my favorites for prototyping. Prototype is doing this, right? Is doing this. A prototype is something that's not final. You can easily change things. So my favorite ones for prototyping are the Uno and the Leonardo because they have the pin headers, so you can just snap things. However, the Leonardo can be MIDI class compliant out of the box. It's really easy to make it MIDI class compliant. And the Uno, some Chinese Unos have a different component here that makes it not possible to make it MIDI class compliant, and then you need another software together, which is Hearless MIDI, to convert serial to MIDI, and that's super clunky, it's super buggy. I'm going to try to avoid as much as I can using Hearless MIDI, and I advise you to do so. And favorite for final projects is the Arduino Pro Micro and the Tinsy LC. I have a Tinsy in a project here. By the way, spoiler alert, project that's coming on in the near future. Okay, so the Pro Micro and the Tinsy LC. Why? Because both are tiny, they can fit in any enclosure. The Pro Micro, because it can be MIDI class compliant and is super cheap. The Pro Micro, you can pay like $3 on AliExpress, $4. And the Tinsy LC, because also it is MIDI class compliant, it's super fast. And by the way, all the Arduinos are fast enough for MIDI controllers, okay? Don't get fooled because you need a faster Arduino for a MIDI controller. But anyways, if you're going to do more things, use all the types of sensors, maybe you want a faster controller. And the Tinsy LC also has more pins, but it's a little bit more expensive. How to use Tinkercad. Okay, so now we're going to start our interactive section of the course. So let me open here something. Oh, and by the way, in the description of this video, I left all the links So you're gonna find the link for the Tinkercad, and I left a link for the materials. So here you have all the materials I use, and you can buy them from Amazon. So you can buy them from Amazon or use them as a reference to buy your own stuff in your town. Okay. So guys, now I want you to join me. Okay. So go to the description and click on the link tinkercad.com/join class. Okay. And there's a number there, a password that you're going to type here, and you're going to press go to my class, and you're going to join with email, not nickname. I'm going to join with my Google account, so I advise you to join with your Google account. I don't know why it's taking so much. So meanwhile, do that. I'm gonna try to do it again. I don't know. So meanwhile, I'm gonna see if you have any other questions. Let me see here. Hi Nerd Musician, is there a possibility to have a MIDI controller where the pitch is determined by something hooked to electrodes? Yes, yes. So any sensor that you have can be used in the Arduino, and sorry, I'm connecting here my Tinkercad stuff. Okay, so, okay, let's see the question here. Meanwhile, try to join the Tinkercad classroom and use that number, and you should see something like this. So go to classes here. So yeah, so by electrodes, I don't know if you mean those things you can put like in your body, in your head. If you can get electric signal from there and connect into the Arduino, yes, you can use this signal because this is only electric signals, and this is going to be converted into digital numbers from 0 to 1023, and you're going to use this signal, these numbers, to whatever you want. For example, you can map those numbers to notes or even to pitch bend, for example. So you can bend the pitch depending on the electrodes, depending on the brain activity of someone. I went to an art installation this weekend that the guy had a sort of a lamp with a sensor that could track your heartbeat through your hand. And this heartbeat was used to change like 1,000 lights in the room, in the rhythm of your heartbeat. So yes, you can do it. André Solis say, fun fact, Pro Micro is now available with USB-C. Yes, thanks for joining, André. Also, Sharon did a MIDI. Any tips for using a Mega? The Mega works in the same way as the Arduino Uno. There's no difference, but I recommend you to use those that I told you. Amazing, what's the name of the library to control the mouse? I don't remember from the top of my head, but put character mouse Arduino library on Google, you might find it. I would like to use analog joystick from Note game controller to move the... I've seen a bunch of people using joysticks. Looking for a DAW output multiplexer to control servos. Ah, nice. So yeah, you can get MIDI from your DAW and use it to control motors. right? And make an art installation, so you can put like envelope followers and get the envelope, the dynamics of your music, and transform that into MIDI, and then use that MIDI to go to the Arduino, and then the Arduino to control motors. And then so much you can do. I had a buddy build a working EEG theremin. Wow. Yeah, so you can do it. ESP32. Okay, so let's go on. So I already connected with my Google account. Come to classes, DIY MIDI controller, open DIY MIDI controller, and here you are. So again, classes, find DIY MIDI controller, and here. Tell me in the chat if you can get to here, okay? So, now, let's use buttons, okay? So let's take a look first here. First, just a little bit about buttons, then we're gonna come back to the Tinkercad. Buttons. A button is a momentary switch, which means that it only closes the circuit when it's pressed. Is momentary. When you release, it's over. So when looking for a button, look for a momentary switch, okay? There's different names, such as momentary switch or SPST, which is single pole, single throw. Basically, it's those buttons with two terminals. So we want buttons with two terminals here. It's the easiest way to do it with MIDI controllers. So it allows the current to flow through it when it's pressed. So when you press the button, you allow the current to flow through the button. So the pin of the Arduino can read when there's voltage or not. For our use, one terminal goes to digital pin and the other to ground. So let's go to Tinkercad and open this one here. This one here, button. And copy and tinker. So here is our Tinkercad, and you see that there's a button here. If you press the middle button of the mouse, you can move. And what we are doing here is that, how do we connect one button in the Arduino? One terminal goes to a digital pin, and we have these 13 here as digital pins. But don't use 0 or 1, okay? Use from 2 to 13 here. These are used for serial communication. They can be used for other things, but just start with 2. So one pin goes to 2 and the other pin goes to ground. So that's how we wire a button. It can be here, any digital pin, okay? So those are digital and those are analog. Now, let's see the code. Wow, lots of things, but you don't need to understand everything in the beginning. Arduino works like this. You learn copying people's code, and then you start to see what's going on, okay? But what we want to do here is that in this code, if we start simulation, what it does is that when you press it, it turns this LED on. See? So if you wire a button like this and use this code in your Arduino IDE and upload this code to your Arduino, it's going to work, okay? Because it is working here in the simulator. So there's a question, can you explain normally open versus normally closed buttons? I've made that mistake more than once. So open means that the current is not flowing. Imagine that you have two terminals. In order the current to flow through it, they must touch each other. They must close. So when it's normally opened, it means that the current will not flow unless you press the button. When you press the button, the button closes the circuit. It closes, it touches two terminals, and then the current will be able to flow through it. Okay, so that's how you wire a button. So now let's come back to our projects and let's take a look here. Let's take a look here in the potentiometers. So now a potentiometer is a little bit different from the Arduino. Sorry, from the button. Just a second. A potentiometer is a variable resistor. It changes its resistance when you move the shaft of the potentiometer. And what does it mean? It changes the amount of current flowing through it when you turn the potentiometer's knob. So remember that the Arduino has 5 volts. There's 5 volts flowing here. But when you turn like counterclockwise, it increases its resistance. So the more resistance it has, the less current can flow through it. So physics 101. So the more resistance you have, the less current can flow. So you can read in the analog input how much voltage is getting to the pin. So when it's here, for example, it's going to be 0, and then it's going to increase until 5. And then this difference in voltage will be read in the analog pin, and then this will be transformed in numbers. Each potentiometer has a maximum resistance measured in ohms. Potentiometers can be linear or logarithmic. Linear is that when you do this, the response is linear, a straight line. Logarithmic potentiometers, when you do this, they do something like that. Usually you use logarithmic potentiometers in audio because our hearing is not linear. Our hearing is logarithmic. It's crazy. So that's why you have a logarithmic curve in audio potentiometers. But with MIDI, we want them to be linear. So let's use potentiometers that are linear with a maximum value of 10k ohms. Okay, for example, I have here one that's actually 5k. So you can see here B5k. My 10k are in my circuit. So B means that it's linear, and 5k means that its maximum resistance is 5,000 ohms or 5k ohms. So let's come here to our potentiometer here in Tinkercad. And copy and tinker. And here you can see how you can wire a potentiometer. So here you have the potentiometer. So this leg here, if you look the potentiometer, the leg in the left, go to ground, which is this pin here. The middle leg, also called wiper, goes to one analog pin, can be from A0 to A5. And this third leg goes to 5 volts. So the Arduino, differently from the button, has 3 terminals. One goes to ground, the other one goes to the analog pin, and the other one goes to 5 volts. So we can take a look here in the code. And what it's doing here, it's outputting its reading. So if we start simulation, if we move here, we can't see anything. So we can click here in serial monitor. Now you can see that we have a reading from 0 to 1023, which is the minimum and the maximum of the potentiometer, okay? So that's how you use a potentiometer. Let me see if we have any questions. Does a potentiometer has to be a knob, or can it control the variable resistance with another form of physical control? A potentiometer is this, but you can control this analog input with many other things, with like infrared sensor. The infrared sensor will be connected maybe a little different. You can use a light sensor, you can use a distance sensor, you can use a pressure sensor. In the end, they all will give you the same range. They will be pretty similar in the Arduino IDE. So they will be really similar to potentiometers, but the way you use them is a little bit different. So the legs of the potentiometers are really small. How do you make them fit in the Arduino chip? So you don't really fit the potentiometer in the Arduino. We're gonna see how we actually do that, okay? So next, let me come back here. So next we're gonna see the breadboard, okay? So the breadboard is this thing here. So you asked about how you fit the potentiometer in the Arduino. You don't. You actually fit them in the breadboard. See? You can fit them here in the breadboard. Let me put in the right place again. And we're going to talk a little bit about the breadboard now. So, the breadboard allows one to make connections without having to solder anything. So in your final project, you're going to solder things, right? I have one here that it's broken, so I can show inside. So here, it's all wires. You can see the Arduino here. So I'm soldering wires into the Arduino, and then those wires, let me full screen this. Then those wires go to the buttons, go to the potentiometers, and that's how you do in a final project, if you are using wires, right? You can also use printed circuit boards, if you design your printed circuit boards. But mostly you will be using wires. And for example, here in the potentiometers, I soldered the wires into the legs. But here with the breadboard, you don't solder anything. You just use jumpers. You snap one jumper and you connect one thing to the other using jumpers. And how do you use the breadboard? It can get a little confusing, but let's see. So the breadboard, which is this thing here, below this top part, you have this. See? So in each conductive material, you have many holes. So you can put a jumper in one hole, and if you put another jumper in the same column in another hole, you are connecting both of them. And if you connect two in this column here, they are both connected. So you have those many columns that you can use, and you have these two lines here and two lines there. So we're gonna try to understand now how can you build a proof of concept in the simulator using the breadboard. So how can we get all those things together in Tinkercad and try to understand how to do this with the breadboard? So now let's open this other project here, the DIY MIDI controller. Copy and tinker. Hey David. David is here. We almost had the live with David yesterday, but we're gonna have hopefully in the next few weeks. Okay, so I am here in Tinkercad. So what's going on here? So see what happens when I pass my mouse in a column. The whole column gets green. Or here, the whole column below here gets green. This means that this whole column here is one thing. This whole column here is one thing. And here, this whole line here is one thing. And this whole line here is one thing. So why do we use this? So for example, if I want to connect one leg of this button in the digital pin and the other leg in ground, remember that's how we connect a button. How can we do this using the breadboard now? I am going to put my button here, a tactile button, in the middle of the breadboard. Why in the middle of the breadboard? Remember that this is one leg and this is the second leg. So one leg, another leg. So because one part of this leg is here and the other part of the leg is here, I'm basically creating a bridge between all these two here, okay? So since I'm creating a bridge here, if I put a wire in any part of this column or in any part of this column, I am touching this wire in this leg. Because this leg is connected to this conductive material here below these holes, okay? So, if I want to connect this leg to one digital pin, I can just put one jumper in this column and the jumper into a digital pin. So this digital pin here is connected to this leg. And this other leg here now is connected, you see this wire here, is connected to here. So why am not connecting this to ground, like this? I could, but since there are several components that have to be connected to the same ground, which we call a common ground, I'm connecting this whole line here to ground. So anything I connect in this line now is connected to ground. And I'm doing the same for the 5 volts here. So anything I connect to the 5 volts here, or to this line, is connected to 5 volts. So this is called a common 5 volts or common ground. And the way you do this with wires, you have to actually wire one wire to the other button and the wire to the other button and always to one leg to the other leg to the other leg, because all the Arduinos share the same ground. Okay? So if I do this, there's no problem, because here is connected to this, which is connected to ground, but this is already connected to ground. Anyways, I don't want to get this more confusing. This might be a little confusing at first, but don't worry, it's going to be really familiar. So one button is connected to pin 2, the other is connected to pin 3, the other is connected to pin 4. My first potentiometer is connected to analog 0, and my second is connected to analog 1. And remembering, one leg to ground, one leg to 5 volts, one leg to ground, and 5 volts. So, if we start the code and start simulation, If we open the serial monitor, if I press this, I can see now button on, and if I release, button off. Button on, off, and this now, you can see that I have 0 to 127, and here 0 to 127. This is because I already prepared my code to send MIDI. So if you do this correctly in your breadboard and update and upload this code, and if you see in the serial monitor this exact information, it means that your circuit was done right. If you have problems, if this is not showing on-off, or this is not showing you this reading, it means that something is wrong in your circuit. Then you need to take a look again in your circuit. Let's stop simulation. And here, we're going to take a look at that later. But for example, if I want to add, if I want to delete one potentiometer, let's delete this. I'm going to delete the wires. And I'm going to add one button. How can I do this in the circuit and in the code? So let's try to do this. One leg goes to a digital pin. Let's go to our next available digital pin. Let's make it beautiful. And one leg goes to ground. I'm going to make the ground wire black, because we always use black for ground and red for 5 volts. So how can I change now my code? Let's see the code. It's pretty easy. In line 47 in your code, take a look in line 47. 46. It says here total number of buttons. Here you just put the total number of buttons. How many we have now? We had 3, now we have 4. Then in line 47, pins of each Arduino button, or pins of each button connected straight to the Arduino, or just pins of each button. So remember that this one was pin 2, pin 3, pin 4, and pin 5. Now I just need to add the 5 here. This needs to be separated by commas. Don't delete those curly braces and the semicolon, otherwise the code won't compile. Just add or delete things followed by comma, okay? And for the potentiometers, you find here line 61 and total number of pots. We had 2, now we have 1. And this one here is connected to A1. We can connect to A0 or just leave it as A1. So now let's start simulation. So there's something wrong here. Oh, see that I got this red terrible error. Too many initializers. So what have I done? Now I have 4 buttons. So stupid here, didn't put 4. So I need to put 4 buttons here. So let's start simulation. Perfect. Now the code compiled. So let's see here. Oh, there's something weird happening. That the code... Let's stop simulation. Let's check things again. We have everything correct. 4 buttons. Okay, was some bug in the software. But anyway, so now we have button 0 on off, and our next button also works. And now we have the only potentiometer working, okay? So that's how you do it. That's how you assemble your circuit in the breadboard. And doesn't matter if it's here, doesn't matter the exact position of the button in the breadboard. It matters if you understand the concept, okay? How to use the breadboard. So now let's come back to our presentation here. And let's build a MIDI controller in real life. Okay. So questions. I know that's a lot. Hope you got something working. So how I copied the button, Command C, Command V, Control C, Control V. So pretty straightforward. Why use the analog ground instead of the digital ground? So let's take a look here again in Tinkercad. Actually, there's only ground. There's no analog ground and digital ground. So all the grounds are the same ground. So we have one ground here, and one ground here. They are all the same ground. Doesn't matter if you connect here, here, or here, okay? Line 46, you didn't change to 4. So yeah, you saw that there was a problem. How did you quickly learn? Do you see how there's, I see. Okay, came in. Will this be online afterwards? Yes, it will be live. I mean, you'll be able to watch it until next Tuesday. Then I'm going to put down and just leave it inside the courses, okay? Woof! Okay, so let's build it in real life. Where am I? Okay, so how do we do it now that we know how to do this in the simulator, okay? You basically do this in real life. I'm not going to do it step by step because it's going to take a lot of time. But I have here basically the same thing, okay? I have 3 buttons, but now I am using my Arduino Pro Micro in the breadboard. And I'm connecting one leg of one button in the pin digital 2. This second button here, one leg of the button in pin digital 3. This one in pin digital 4. These 3 here are the ground. So see that I'm connecting them to the same ground. And I am connecting this ground with this ground. So I'm doing a jump from this to this. So like now, this blue is connected to this blue, and this red is connected to this red. So it doesn't really matter in which side I connect, as long as I connect the grounds in this ground or in this ground. Because this wire here, this ground here is coming to my Arduino ground pin. And this orange wire here is coming to my Arduino 5 volts pin. So I am powering these 2 rails, these 2 lines and these 2 lines with 5 volts and ground too. Okay? And my potentiometers also are connected to A0, A1, and I have here ground and 5 volts, ground and 5 volts. Okay? So here in the breadboard, as soon as you understand how to do it in the simulator, it's really straightforward. So now that's done, we need to now make it a MIDI controller, right? But now we need to make it, or we need to use it in real life. So for that, we are going to have to download the Arduino IDE. This you can try to do later because you're not going to have time to do everything in real life now. So this is the Arduino website, arduino.cc. I have the link in the description. Come to software. And I prefer to download the previous IDEs, like this 1.8.19. The newer one is still a little clunky. I'm not really used to that. And you can download this one to your OS. So of course already downloaded. Next thing you're going to do is downloading the code. So I also left the code in the description, which is this github.com, Silveira DIY MIDI controller. The way you download is coming to code and then download zip. And then you're going to open your Arduino IDE, which starts like this. It's pretty scary because it doesn't have anything, right? But you can just go there and open my code, which is this. It's a file that's .ino. Let me just open here, show you here how it's going to be for you. So when you download that folder, you're going to have this. You have the code commented in Portuguese and the code commented in English. And also you have the schematics here, so you can use it. So then come here and open this file. And here we are. We came a long way, and now we are about to make it a MIDI controller. But first, one really important thing. We need, oh, there's a car really loud right here. Sorry. We need to install the MIDI USB library. The MIDI USB library will make your Arduino a MIDI USB controller, plug and play MIDI USB controller. And that can be used with the Arduino Pro Micro, the Arduino Leonardo, and the Arduino Micro, which have the chip ATmega32U4. Make it bigger for you here. So first we want to do is checking in the serial monitor to see if we wired things correctly. But before, I almost forgot, let's install the MIDI USB library. So you come to Sketch, Include Library, Manage Libraries. And here in the Library Manager, you're going to type, as soon as I can, MIDI USB. And press Enter. You're going to find this MIDI USB version whatever, and you're going to press Install. That's all you need to do. Okay, so first thing we want to do is checking if everything is working in the serial monitor exactly in the same way we did with the simulator. So to use this code in the serial monitor, you need to change this to debug. So this thing here is where you choose the type of Arduino you are using. Actually, this code, you can use the Arduino Uno, Mega, Nano, but then you're going to need to use Hairless MIDI, or you can use Micro, Pro Micro, and Leonardo, or you can use Latency, or you can use it in the debug. So I'm going to copy and paste. So here, I want to leave in debug so I can see things in the serial monitor. Also, if you can see the lines here, if it's helpful for you, you can come to Preferences and Display Line Numbers. Next thing is changing the variables or changing the number of buttons, pins, etc., just like we did in the simulator. So here in line 47, we have 3 buttons. So here in my project, that's what I have. So I'm not going to change anything. Actually, the code is already exactly like I need, but know that here is where you change things. So 3 buttons, and here the pins. So I am here in pins 2, 3, and 4, and here in the A0 and A1. So 2, 3, and 4. So let's go a little bit down. Potentiometers. 2 potentiometers. Great. Pins A0 and A1. So for analog inputs, you need to put capital A before. Okay? So capital A, and in the digital you don't put any nothing, just a number, okay? Digital is just a number, and analog is capital A followed by the pin. So here we have the number of potentiometers and the pins. That's all you need to do. But there are other things you can do. For example, here in line 80, you can change the MIDI channel. You can change the lowest MIDI note and the lowest control change. So what does it mean? So this will be the lowest MIDI note. Let's say if I put 36, this will be the 36, which is a kick drum. Then this will be 37 and 38. I don't have here in this code how to change each one, but I teach how to do that in the complete course, in the Nerd Musician Pro. Or map things, map like solo, record, play, stop, trigger clips. And potentiometers will be used to control things, to send control change, which can be used to control volumes, cutoff filters, etc. Okay, so questions before we go on? Let me see. Code, which is here, we need to select the board we are using. Here we have boards. You won't find Arduino Pro Micro because it's made from another company, SparkFun. You can install Pro Micro, but you won't find here. But remember that I told you that it's the same chip as the Leonardo or the Micro. So you can choose either Leonardo or Micro. The only difference is that it will show up as Leonardo as the name of your MIDI controller. So Leonardo here. And here in port, you need to choose the USB port that's connected. Mac will be cu.usb modem, and in Windows will be something like COM4, COM5. So choose them, okay? Press verify to see if you have any problems. So for example, if you have something that should not be there, it's going to show you an error, and here will tell you something hopefully helpful to find where the error is. Okay, so let's verify again. Done compiling, so I don't have any problem. See here how much of memory I am using. Sometimes you exceed the amount of memory and you can't compile. So let's press upload, remembering that we are in debug. And yes, we're going to have live in Portuguese, probably next month. So done uploading. So here is the serial monitor. One thing important in the serial monitor is that you need to choose here the baud rate, which is basically a frequency that the serial monitor communicates with the Arduino. And for our code, I always leave in 115200. So when I press a button, I should see now button on off and button on off, button on off. So this means that my buttons are wired correctly, and this means that when I make it into a MIDI controller, it will work. So always make sure it's working in the serial monitor, right? And here also working perfectly. So if this is working in the serial monitor, you installed the MIDI USB library. Now, when we change to this, so now I want to make it into a MIDI controller. So I am using the Pro Micro. So I want to copy this and paste here. And now upload. So now if there's a software I use which is Midi Monitor. I also left the link in the description. It monitors the MIDI incoming message. So for example, I can know which notes, which message I am getting, okay? So I can see here in my MIDI sources that I have Arduino Leonardo. I have my audio interface and I have an Arduino Leonardo as a MIDI controller. How cool is that? So if I press now, oh, I even have sound. I don't want to make any spoiler. So see that I have note 36. When I press, I have velocity 127. And then when I release, velocity 0. Note 37 and 38. So velocity 127 is note on and 0 is note off. If you have velocity, you're going to have more than 0 and 127. But here we don't have velocity sensitivity. So it's just on or off. And then my potentiometers here are sending MIDI control change 1 and MIDI control change 2. Okay, so I know that I have a MIDI controller. So what we can do now is coming to Ableton, and I'm gonna delete this. So for example, if I want to play a drum kit, I'm going to add here an 808. So now if I press here, so I have a MIDI controller. So if I put any other instrument, like a piano, for example, doesn't really matter. And one thing that's important, at least in Ableton, here in MIDI, here, see that I have here in my Arduino Leonardo, for you to play notes, track has to be on, and for you to map things, control things, remote has to be on too. So always leave both on. Since we are not using LEDs or things like that, you don't need the outs. So let's come back to our drum. And for example, now I have a reverb in my send 1 and in my send 2. I can start my MIDI mapping, click here, then move the knob, then click here, then move the knob. You can see that now I have full control. So if I play, or the delay, and it's super responsive, like it's not slow at all, it's just like a normal potentiometer. So yeah, I guess we have a MIDI controller, and I know we did like all of this in 2 hours already. So you see that can be done fast. So I just gonna touch a couple other things now before we finish. Let me see if you have any questions. When you connect things, so cool. Any tips to reduce latency? It's hard to say exactly how to reduce latency. I do that in the code as the best as I can. For example, I read the buttons as fast as I can, and I read the potentiometers just every X milliseconds. So I'm not reading the potentiometers all the time. This way I can read the buttons faster. So there are some tricks I do in the code, so I try to make it as fast as possible, but also in your DAW, to reduce latency, you can reduce here the buffer size. Okay then, let's come back to my beautiful presentation. Let's talk a little bit about enclosures. For example, this guy here. So this one broke. This one didn't. Both fell in the floor. Guess why this didn't break? Because this is wood. This is acrylic. So it really depends on the material you use. But the process I use to make them, it's pretty similar. I use a design software such as Fusion 360 or Inkscape Illustrator. Fusion 360 is 3D. Just a moment. There's always some nasty comments every live. So enclosures, again, I use them or I design them in Fusion 360 or Inkscape or Illustrator, and then I usually use them, make them in acrylic or wood, and so I design them in a software, and then I export 2D files so they can be cut in a laser cutter or a CNC machine or even 3D printed. So here you can see the process of building one. Here I'm using Fusion 360. So I have a template in Fusion 360 that I always use. And Fusion is parametric, like you can just change some numbers and the whole design gets adapted. And then I just cut some holes and in the design, as you can see. And then I put the holes for the components I'm going to use. And then I send this to a laser cutter. I have a company here in my city that they do laser cutting. So you have to look for in your town. Worldwide, there's Ponoco and Sculptio. Remember of putting this in the, I'm gonna put in the comments, Ponoco and Sculptio. Google those words and you will find companies online that you can just send your design and they will cut for you. I also teach how to design all this stuff inside the courses. And now mount the components and solder them. So after you did all this stuff, let me get a video here. You need to take your schematic. Sorry if I lost my video. Oh, sorry, I lost my video, so I'm gonna find here. So once you're ready with your design, with your schematic, you can do the same process, do the same thought process of doing in the breadboard, but now with wires, right? Once you know what goes where, and you understand the concept of a common ground, you know that every leg of the button has to be connected to the same wire or the same ground, so you can just do one wire to the other. You know, you can just do your circuit in real life, just like here. So we have one schematic here in Tinkercad that is this one. So for example, you can do this with the Arduino Uno. I'm using all the inputs. You don't need to use all of them, but you can use this same idea here to do it in real life. So I am going to play you a video of me doing this in real life, and I'll be right back. Oops, that's not the right video. I'm sorry. That's this one. Yeah, so let's come back here. So that's one of the things you can do. And of course, then you're gonna have to learn how to solder, which is the next step. And sometimes you make like sloppy soldering, you make mistakes, but then you start to get good. So it's always important to start small. But again, once you understand the process, it's easy to come back, or it's easy to go to a final project. Okay, so now next step would be, this is optional, this is totally optional, which is building a printed circuit board. So this is a printed circuit board. So why would you do that? This removes all the wires of your circuit. So there are copper traces that you can't see here that are doing the wire roll. So you don't need wires. So this makes your projects way faster to assemble. So once you design your PCB, it will help you to get rid of wires, make the building process faster, It's scalable, so if you want to sell, for example, a lot of my students now are selling controllers, and making PCBs is really important because it's way faster and more professional and good looking for you to sell a controller. I use KiCad to design my PCBs, which I also have the course, the KiCad PCB design, but there's also Easy EDA. Both are free. Here are some of the PCBs I have done. There are many others. And now how to expand your MIDI controller, right? So we did a lot. We learned a lot today. We learned about the Arduinos, how to use the breadboard, how to use buttons, how to use potentiometers. But what if you want to use rotary encoders? Rotary encoders is a big thing. It's different from buttons, it's different from potentiometers. It's digital, but it looks like it's analog. How can you do that? How can you use motorized faders? How can you use addressable LED strips, or things like, I think I lost my video again. But anyways, how can you use addressable LED strips? How can you the motorized faders? Or how can you use different types of sensors? How can you do physical MIDI? Lots of things that I can't cover here. Or how can you increase the number of inputs and outputs of your Arduino? Increase the number of buttons if you want to have like 100 buttons, 100 potentiometers, 100 of LEDs. If you want to add addressable LEDs, control lights, like we're doing this. So many things you can do. So many things you can do. Besides buttons and potentiometers. Buttons and potentiometers, you are covered by most of your projects, but there's a limit. Most like pin limit and things like that. So what can you do? So I lost my presentation again. Just a second. Come back here. So how to expand your MIDI controller? So I told you that I was going to talk about the Nerd Musician Pro. So the way I can manage to be able to do free content, to do YouTube, and it's a lot of work. You can't imagine how much work I put in all of this to build this live. There's so much going on, and for me to live all of this is I need to get paid somehow, right? Some people do Patreon, I do paid courses. And the Nerd Musician Pro is actually a 3-course bundle. You have the Making Music with Arduino, the Arduino Programming, and the KiCad PCB Design courses. With these 3 courses, plus closed community, plus my contact, like people contact me all the time, you get my WhatsApp, my email, and I help you with your doubts. With that, you can build virtually anything you can think of. If you saw my students in the student showcase this week, you saw that they had the most different projects. And they at least, they start with the Making Music with Arduino, which is where I teach how to build the MIDI controllers in the easiest and in the fastest way possible. But then they need to do something else. Then they take the Arduino Programming, where they learn how to program the Arduino, and maybe they want to sell their controller or make it faster. They take the KiCad PCB Design, right? Or you take the 3 of them at the same time. So what is the difference in the 3 of them? So the Making Music with Arduino, which is this one in the left, I teach in the same style I taught you here today, only adapting my code to your needs. You're just going to go there and change some numbers. Really easy and fast, okay? Buttons, potentiometers, I teach how to do high resolution too, how to increase the number of inputs and outputs, how to use rotary encoders, how to use banks, addressable LEDs for note feedback, normal LEDs, how to use motorized faders, how to make MIDI class compliant devices with the other Arduinos too, how to design and fabricate enclosures. I have a whole course on that. About all the materials, I have a huge list of materials, suppliers, where you can buy them. How to troubleshoot, I teach this. This is really important. How can you find the problems in your own code? I know that some people that started, they get stuck because they don't know how to go on. So I teach how to troubleshoot, and also you have our community where there's lots of students that help each other, and there's me. Again, you have my contact. Also how to use displays. If you saw my students in the past, in the student showcase, they used displays in very clever ways. Makes your controller really flexible. Also you have bonuses. You have access to all my codes, templates, and designs. Access to our Facebook group, where I will help you with your doubts, and you can meet other nerd musicians, and my personal contact. Here's some controllers that I have built. Things like, if you learn how to build your MIDI controllers, you can make yours too. You know that controllers for plugins, crazy guitar, light alien controller, controller for DJs, launchpad with RGB buttons, more controller for DJs, more launchpads. Then we have the Arduino programming course. Is where I teach everything about the Arduino programming, where I'll teach you how to write your own code, how I have written my codes, and how can you understand other people's codes, right? Because you see that and they're like, what the heck's going on? I'm gonna teach you how to write yours, and how can you understand other people's codes so you can use theirs and adapt them to you, to use in your favor. This will take your maker skills to the next level. It will allow you to create anything that comes to your mind. I'll teach you the programming language while I focus everything in making music. So that's how I was able to build something like this crazy thing here, or add lights to this kind of project, okay? And then, and this, for example, this that it has encoders with like RGB encoders, pressure sensors, addressable LEDs that change color, soft potentiometers that track the position of my finger, tons of things that I did thanks to my knowledge in programming, okay? Which I learned being a musician, okay? No background in electronics or programming. Then the KiCad PCB design, which is also an online course that will teach you how to design and manufacture your own printed circuit boards, your PCBs. And during this course, we will design one PCB from scratch, showing the whole process until fabrication. This course will allow you to make your electronics products faster, more reliable, and look super professional. Here a PCB I have done, which I showed you the picture. I'm going to show you how you can design this in the software and how can you send this for manufacturing, so you can get this in the cheapest price from a Chinese company. Okay, so how much the Nerd Musician Pro costs, okay? Usually, like, you can purchase each of those courses separately, and each of them cost $97. Total $291. But until next Tuesday, only in the next couple of days, I'm giving a special discount, okay? So if you enjoyed this live, 2 hours live, imagine what I can teach you in like 20 hours of content. I don't know if I have 20 more, 30, I didn't count, but that's a lot. And it's all you need to build any type of MIDI controller you can think of, okay? It will save you months of research, and it will save you hundreds and hundreds of dollars. Because instead of paying $200 in a controller, you can pay $40. Instead of paying $500, you can pay $90. And you can build MIDI controllers the way you want, in your style, with your personality, right? I love this, and I think you will love too. And when you start building stuff, it's just the beginning. You get addicted and you can really change the way you make your art. And only in the next few days, until October 18th, I'm giving 60% off. So instead of $291, it's only 117, only until October 18th. The link is here in the description for the Nerd Musician Pro with 60% off. But for you, only for you that watched the live, only for you, my friend, that watched the live, as a thank you, I'm giving you an extra discount, okay? So only to who watched the live, an extra 20 off. Only for you. I'm not sending this to the email list. I'm not sending this to anywhere else, okay? Only for you, and that's only today. I'm going to leave the coupon on only today. I'm going to give you 66% off. So you're only paying 97. So you're paying only one course. You're getting 3 courses, paying just one course. That's only today. So for that, you have to use this coupon, and I'm going to show you how you can do it. Okay, so that's the end of the presentation. I'm just going to show you how you can apply the coupon. So if you go there to the description, you're gonna find this page where you have the 60% off. You can buy in the next days. If you missed the discount, the extra discount today, you can use the 60% off for the next days. You have all the explanation with all you need. You have here until when you can use this discount. And if you just click here in Enroll Now, you can get that coupon code that's in the description. You can remove this coupon. See that it's 117. You can remove this coupon and apply that other one. And then it's $97. Okay, and that's only today, just for you that watched the live. You can get the 3 courses, the whole Nerd Musician Pro course bundle, paying for just one. Okay guys, so if you want to build the MIDI controllers of your dreams, anything that comes to your imagination, potentiometers, buttons, encoders, motorized faders, LEDs, physical MIDI, displays, how to program, PCBs plus community, and all of that, you can join the Nerd Musician Pro today for only 97, or if you're watching in the next days until the October 18th, next Tuesday, for 117. Okay, then the price comes back to its original. And if you don't want to buy it, you also have until Tuesday to watch this video, do whatever you want, save, I don't know. It's already enough for you to get started, to build MIDI controllers with buttons and potentiometers, or even for you to do your own research and go from there. Okay guys, so questions, let me know what you thought. And oh, by the way, one last thing. All those slides I used in this live, if you type in the comments of this video, send me the slides, I'm going to send to each of you that comment in the video, send me the slides, okay? I'm not going to send you today because I need to rest, but tomorrow or this week I'm going to send you all the slides so you can have all the text for you. It's going to be great. It's going to be easy, okay? So yeah, comments, please let me know. Thank you so much to stay until the end. It's like, wow, 2 hours and 20 minutes. We're gonna do 2 hours, 2.5. So instead of put in the chat, put in the comments of the video. Put in the comment of the video, okay? Because in the chat I'm going to lose, and I don't know how to send you. But if you put a comment in the video comment section, don't need your email. I'm just going to put the link so where you can download the file, okay? So just send me the slides in the comments of the video, not in the chat, in the comment. Just send me the slides, and I'm going to put the link so you can download. Okay guys, any other question, anything? I hope no brains were melted. And I really hope you can take this and build something. And if you build anything, please tag me on Instagram, okay? And of course, subscribe to this channel. The Instagram is Nerd. I have the info. If I didn't put in the comments, I'm going to put also the Instagram. Thank you, Taha. Thank you, Michael. Thank you, everybody that was in the chat. I don't know if you have any more questions. I know there was a lot, and I'm glad that everything worked with the live. This means that I'm going to be doing more lives more often, and I'm also going to do probably next month a live in Portuguese, okay? I would do in Spanish if my Spanish was decent, but es una mierda, entonces only in English, okay? So can you quickly explain multiplexers? So I don't have any multiplexer here in hand, but the way a multiplexer does is that it gets one input of the Arduino, one analog input of the Arduino, and then it connects in this same input 16 other inputs. But the 16 other inputs are not read at the same time. What it does is that it reads one, then the other, 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 one after the other, really fast. So it's like you multiply 1 into 8 or 16, depends on your multiplexer. So there are ways you do that in the code, and there are libraries that help you with that. And in my code, in the complete code inside the course, I make it really easy to use the multiplexer tool in the same style we did with the potentiometers. You just tell like in which pins you're connecting the multiplexer. So basically the multiplexer only takes, I guess, 4 digital pins of the Arduino and the analog that you want to multiply. So the 4 pins are the controllers, it's how you control the multiplexer, and the other one analog you multiply into 16. So for example, if you have in your Arduino Uno that has 6 analog ins, you can multiply by 16, so you can connect 96 components. In your Arduino Uno, if you have 6 multiplexers, 1 multiplexer for each analog input. Because all the multiplexers only take the same 4 digital pins in the Arduino. So it's not like extra 4 pins for each multiplexer. So they have common control pins. You only add 1 extra analog input for each multiplexer. The issue is that when you add lots of multiplexers or lots of components, each component take a space in the memory of the Arduino, because you need to declare one component, another component, and every time you declare a variable contains one information for each component. So every time you declare a new variable because you have a new component, you take a little bit of memory. So depending on the Arduino, for example, the Arduino Pro Micro, it has a memory limitation. So then you need to think which Arduino can you use. Like the Arduino Mega has more memory. The TNC-LC has more memory. So if you want to use lots of multiplexers, I would recommend using the TNC-LC, for example, because then you can go like hundreds of components. Yeah, so again, please put in the comments, send me the slides, not in the chat, because I can't send you the... Maybe I can, I don't know. I don't think I can send you in the chat, okay? And it helps for the video to have more comments in the video. Okay, guys, so thank you so much. I really enjoyed, really happy. Thank you for staying until the end. It was a blast. Hope you enjoyed. Feel free to send me an email, Instagram message, WhatsApp, whatever. Okay, so thank you so much. See you next time. Bye-bye.